This is Unit 2, the atmosphere. This is for day 6 of class. We'll be talking about observing weather and focusing on our local winds. So our learning target is still 2.E. It's observing weather, but today we're going to be able to describe the direction of local winds on land, by the sea, and near jet streams. So our local wind patterns. In general, the land heats faster. It's a solid and transfers energy by conduction. The sun is only going to heat the surface of the earth and not below. That's because the sun can only touch the surface and it can't see through the surface to get to the bottom. All energy is concentrated in the upper layer. Water heats very slowly. It's a liquid and more effectively transfers heat. It's transparent, allowing a thicker layer to be heated, and evaporates and takes heat into the atmosphere, which keeps the water temperature lower. So we have local wind patterns. We have what's called a sea breeze and a land breeze. So in a sea breeze, our land during the day is going to heat up much faster than the ocean. So the land will be warmer than the ocean is. Our air is going to rise because it's hot over here. It's going to rise, which is going to create low pressure here at the surface. Our air is going to be sinking over water because it's cooler over the water, which is going to create a high pressure. Remember, we're compacting the air over here, which means the wind is going to blow into land from the sea. And since it's from the sea, we call it a sea breeze. Our land breeze, this happens in the nighttime. Okay, so now the land is going to cool much faster, but the water is going to hold on to the heat that it gained during the day, which means this is the warmer area, so the air is going to rise over here, creating low pressure. The air is going to sink over on this side, causing high pressure. Remember, our wind always goes from our high pressure to our low pressure, so it's going to come from the land out to the ocean, and it's called a land breeze. Our jet streams. These are narrow bands of fast-moving winds caused by large differences in temperature and the Coriolis effect in the upper air layer. Okay? Storms form along our jet streams and generate large-scale weather systems. These would be the cold fronts and warm fronts that we're used to hearing about. Okay? These systems transport cold surface air towards the tropics and warm surface air towards the poles. Our polar jet stream, this is the strongest of the jet streams, and it's formed between our polar and feral circulation cells. The acceleration and deceleration, or the speeding up and slowing down of this jet stream, helps to create areas of low and high pressures, which creates cyclones and anticyclones. Okay, so here's our polar jet stream right here. Okay. Many of our best snowstorms occur when this jet stream drops below us. Then we have our subtropical jet stream. This is the weaker of our jet streams, and it's formed between our Ferrel and Hadley cell circulations. It's closer to the equator, okay, so it does not affect us as much. Sometimes the two will combine, okay, which will bring us even more severe weather.